Okay, we're going to start off with Chapter 2, Position, Displacement, Velocity, and Acceleration. Much of this should be a review from last year. I'm going to introduce a few new concepts, specifically calculus. I want to break up the chapter into three different lectures. I want to do definitions portion, I want to do a graphical techniques lecture, and a problem-solving lecture. The first one, basically you're going to peruse through, you're going to do it quickly. The graphical techniques one, I want to make sure that you guys have that down. And the problem-solving one is probably going to be the one that you use the most through this section. Okay? So the first thing that I want to talk about is position. Position is your location along a numerically defined axis. This is, in this chapter, Chapter 2, this is one-dimensional. We can have it be either positive or negative. So if I do this, okay, I can have my 0, I can have my positives be to the right. It doesn't have to be to the right, but for the purposes of this case, I'm going to make positive to the right and negative be to the left. Okay, so now, your position is just whatever your location is along there. So let's just say that I'm at this location right here, and I'm going to call that position X, and I'm going to say that it's equal to, in this case, positive 2. You don't have to say positive 2 in each case, but I'm just trying to make the point here in this case. So now, location is not terribly interesting in and of itself. It's very important as the basis for the rest of it, but you really want to take a look at displacement. Okay, displacement is a change in position between a starting point and an ending point. So now, if I'm going to call displacement I'm going to define that with the symbol delta x. Okay? So now delta x in this case, delta x will equal x2 minus x1, where x2 is final location, final position, and x1 is the initial position. Okay? So my delta x is my displacement is the difference between those two. If I start off with, if I say that this is, let's make this x2, and let's make another one, let's make a x1 go like this. So what I do is, for my displacement, I am moving from my left to the right. I go from x1 to x2. So now my displacement goes in this direction. In this case, my displacement, delta x, is equal to x2 minus x1, which is equal to 2 minus a negative 1, which in this case is 3. I assure you it gets much harder than this. So now, in the number one that we have set up, the final position is to the right of the starting position, and this has a positive displacement. If we did it reversed, it would be a negative displacement. Another thing that I should point out is that delta x is a vector. Okay, displacement is a vector. It does have it's the change in position and the direction that it's gone. In the case that we're doing here in Chapter 2, it's all one-dimensional. So we're going to say that our location is either in the positive direction or in the negative direction. So do understand that it is a vector, but we're not going to focus on the vector aspects of it right now. The next thing that I want to talk about is average velocity, because again, your change in position is interesting somewhat, but it really doesn't get into the depth that we really need to go into. So we're going to take a look at average velocity. It is the displacement per unit time. So now I'm going to describe displacement, describe average velocity here. And the symbol I'm going to use for average velocity is V bar. Okay? V bar, this will equal delta x over delta t. Again, I assure you it gets harder than this. There's a few things that we're interested in here. Okay? This is not the speed. It's not the average speed. Okay? What we're concerned about here is, if I break this down, this would equal x2 minus x1 over t2 minus t1. Okay? All average velocity is concerned about, and I talked about this last year, the starting point, ending point, and the time. Okay? Starting point, ending point, time it takes you to get there. That's all average velocity is concerned about. It doesn't matter what happened in between. What happened in between the starting point and the ending point. Okay? Doesn't matter how you got from A to B or from x1 to x2. All that matters is that you started off at x1 and you end at x2. And we'll see what that means when we take a look at average speed, which is our next thing that we're going to talk about. Okay? Average speed looks like the same thing, but it's not quite. Okay? And your book is going to use S average for average speed. We don't really use average speed all that much, so I don't have a problem with it per se. However, understand that S is typically talking about arc length, and the book uses S for arc length later on. Pretty much we're going to talk about average speed here just to help understand what average velocity is a little bit better. Okay? So now S average is equal to total distance divided by the time. So now, they look kind of the same, but let's think about this. And yes, we're going to get into a little bit of a two-dimensional description here, but just think about this. In the 400-meter dash, 400-meter run, what a sprinter does, and it's basically the ultimate in the human sprints. The human body can't sprint any longer than 400 meters, pretty much. What happens is you start at a certain location, especially the people on the inside lane. They start and end at the same place. Okay. So now, what happens is, as you go around the track, you start off here, go around, along straightaway, go around, and then you end back at this location. Okay. So now, let's just say that we are a world-class athlete, and we're going to have our 400-meter time be 45 seconds. So now, we're going to say 400 meters in 45 seconds. We want to calculate the average speed and the average velocity for this case. Noting that you start here, you go around the track, and then you end at the same location. So let's see what happens. For average speed, the total distance traveled is equal to 400 meters divided by 45 seconds. Okay, so now, this will equal, I don't have my calculator on me in front of me, which is unfortunate. Your average speed, therefore, is going to be, so this is going to be 8.89 meters per second. Okay, so that is our average speed. Our average velocity is different. our average velocity, okay, and that bar over top means average. I didn't put the bar over the S because, well, we're not really going to use it again, but V bar means average, okay, average velocity. In this case, it's going to be delta x over delta t. Well, x2 is here. Okay, that's where I end. x1 is also here. That's where I start. So now my delta x is equal to 0 over 45 seconds. So my average velocity is equal to 0 meters per second. And that's the fundamental difference between average velocity and average speed. In average speed, you're not caring about, in average speed, take a look at the total distance that you cover. In average velocity, you just look at the starting point and the ending point and the time it takes you to get there.